Assalamualaikum warahmatullahi wabarakatuh. Greetings, I am Jalur Rafli Ismail, affiliated to Indonesia University of Education, and I'm the presenter at 4th International Geography Seminar. The paper I would present in this very moment is Spatial Analysis on Influence of Elevation toward Infection Fatality Ratio of Coronavirus Disease 2019 in Bandung Regency and Bandung City. To begin, the impact of certain elevation toward COVID cases itself is yet to be decided among scholars. But there are some places showing facts toward the correlation between elevation to the COVID cases, just like Tibet in China and La Paz in Bolivia. Tibet in China is situated in high elevation but located quite close to Wuhan, which is, we believe, as the first location of the COVID outbreak. But there is a question why Tibet, who is interrelated by transportation, by communication, by people movement, can have lower cases than Wuhan. Dispute of that closeness in the distance. And also in La Paz, Bolivia, having more population rather than Santa Cruz, the closest city to La Paz itself. But is elevation the mere reason for the lower cases, even though La Paz is more populated than Santa Cruz de la Sierra itself in Bolivia? And then to assess the fatality itself of the COVID cases, we use the parameter of the infection fatality rates. The infection fatality rates take into account people who are symptomatic and not, people who are diagnosed or not. So it will be a general assessment. And also the IFR numbers is vary. There is no universal parameter toward the IFR for the global numbers. So to make the fatality justification happen in the research, we're going to have a comparative approach to the cases presented. Citing the research of Ting and Alia, COVID-19 is more contagious but less deadly. The mortality rate itself is 2%. The research is taken in March 2020, but the number seems to be relatively relevant towards now, which we are having the cases, the confirmed cases far more higher than the mortality cases itself. Still, even though it is less deadly and more contagious, it hits different regions differently. In the world, we don't have even cases numbers, statistic number of coronavirus itself. There are places who are far more safer, and there are places who are exposed to bigger risk toward a coronavirus disease 19. And we know that Bandung City and Bandung Regency in West Java Province are two locations that hit the most in terms of its confirmed cases and also death cases. But there are also other cities relating to the statistic itself became more higher. But what we look into this is that Bandung City and Bandung Regency has that intense and deep spatial interaction. So that interaction makes us curious of what makes one region having less cases than other. We can actually connect to air pollution, also to local migration, movement of people, that Bandung City hosts more people from other cities, from other regencies, that what make it more dangerous. But in other places also Bandung Regency having more populated than other regencies, densely populated than other regencies around the regions of Jabodetabek, around the regions of metropolitan Bandung area. So what the research question would be is that, is elevation is the mere and good reasoning for different COVID cases, or are there any reasonings? But by far, we know that Bandung Regency, most sub-districts in Bandung Regency are situated in high elevation rather than Bandung City, and that we can connect to the status quo fact that Bandung City is having more cases than Bandung Regency. Methods used in this research is that non-experimental quantitative research to comparative analysis. We're going to have quantitative research where we'll take into account the statistic of confirmed people, infected people, and also the how much death cases from the coronavirus disease 2019. And we're going to compare it to each sub-districts in West Java. So we're going to have the data of confirmed cases and the cases from each sub-districts, and we compare it to the variables of elevation, of population density, and also air pollution into account. Second, we're going to have spatial analysis based on infection fatality ratio. Infection fatality ratio is the formula is the parameter where we can take that to assess the fatality itself based on sub-districts data that I've been mentioned before. The IFR number itself generated from the number of deaths from disease compared to the number of infected individuals. And third, the variables of IFR number analysis for Bandung City and Bandung Regency are air pollution assessment, where we will refer to the index standar pencemar udara, which is equivalent to the United States Air Quality Index, population number, and population density. Now we're looking into the map of the IFR number of each sub-districts in Bandung City and Bandung Regency. IFR number in Bandung City and Bandung Regency spans from 0% to 0.25%. As there is no universal parameter of the IFR itself, we only can refer to this range. But one of the research saying that the range of the IFR itself generally is 0% to 1.63%. So in this categorization of the IFR numbers, we're going to see that 0 to 1.25 is the one for lower in IFR number, and the middle is 1.25 to the 1.63 itself, categorized as medium and also as higher respectively. And also in the highest IFR number in the map shown is in the Cisendo sub-district in Bandung City, with population of 4,200 and population density of 14.69 thousand people per square. The lowest IFR number is in Rancabali sub-districts in Bandung Regency with population 52,921 people, and population density is 356.68 people per square. What we are concluding from that data itself, the place or the sub-district with the highest IFR is actually situated in the low elevation location, and also with having more population density, and the one who are having less harm toward and also are represented in having lower IFR number is the one who is situated in the higher elevation with also lower population density. Generating from the IFR map, we're going to see the variables of IFR itself. The variable of IFR itself is that confirmed number and also that cases. We're going to connect that data into the elevation span in Bandung Regency and Bandung City. Presented in darker color is the higher elevation, to the lightest color is the lower elevation. What we can connect from that figure to the explanation is that the ones who also shows the lowest death number is situated in high elevation. We can see from the diagrams that generally in Bandung Regency death cases are rarely to be found, but it is more significant toward the Bandung City itself. But the interesting fact itself, still in Bandung Regency, sub-districts in Bandung Regency which are situated in lower elevation, take as example Balai Endah, has COVID cases more than other sub-districts in Bandung Regency. So that finding could confirming to the preliminary result that of course elevation has preliminary correlation to the COVID cases. To confirm the finding itself, I would like to first jump into the some things that more raw findings. The raw findings itself, with only comparing the variable of elevation to the statistics, we actually have been confirmed that Bandung City, which is situated in 723 meters above sea level, and Bandung Regency above that, having more cases. So Bandung City with lower elevation having more confirmed cases, it's 200 higher than Bandung Regency, and also having far more deaths. It is about 30 to 34 deaths cases. So it's actually resulting in a higher IFR, in the higher average IFR percentage itself, with Bandung City situated in a higher elevation. So from this preliminary finding, we can really connect it. But we're going to see to the next table to what also supporting this finding. In this table, we are going to also compare the variables of average elevation, air pollution index, population density, and COVID statistic itself. We have talked about average elevation, which Bandung Regency is situated in a higher elevation, and then about air pollution index, which many scholars believe to be the direct reasoning for the COVID cases itself. To actually what makes southern Italy and Wuhan city the same in the similar cases in the first outbreak is that both cities has worst air pollution, and we can also apply that statement to Bandung city and Bandung Regency, which Bandung city having also a worsened air pollution than Bandung Regency. Bandung City record 124 number in ISPU or Index Standar Pencemaran Udara. What does it mean is that this also contain the pollutant, the fine particulate matter or PM 2.5 in amount of 44.8 microgram per meter cube, which is actually categorized in ISPU as sensitive, as dangerous towards sensitive people, and that would mean that people who have existing respiratory and lung disease could expose to bigger harm toward a coronavirus disease itself, which actually resulted in higher cases in Bandung. And air pollution index in Bandung Regency is 25 in ISPU and having amount of pollutant PM 2.5 6.1 microgram per meter cube. This would mean that the air quality in Bandung Regency categorized as good, as healthy for, and having no significant impact toward lives. And this also the reasoning why in Bandung Regency the recovery and also the exposure toward the virus itself is lesser. The population, if we talk about the population, Bandung Regency having way more populated, 1 million people more living in Bandung Regency, but it is also connected to the wide of the areas. But what we talk about is the population density. Bandung city is way more populated than Bandung Regency. That also makes the social distancing less effective, and we know that Bandung city also hosts people in a day, which actually they are coming to having non-formal, informal occupations, that making social distance itself to be less significant, because they are not going to do that in their jobs in Bandung city. So that can also connect to the variables of poverty, of economy, of people's understandings toward the coronavirus disease. But what we're mainly talking on in this research is that we connect the variables of elevation, air pollution index, population, and how it could justify the harm of COVID cases. The final table is going to compare the cases in Bandung City and Bandung Regency. We categorize the city itself with the sub-district itself with sub-district with highest elevation, with highest IFR number, and also lowest elevation to see and confirm how it could relate and how it could prove the title of this research itself. In Bandung Regency, you're going to see that the sub-districts who is lowest elevation is also sub-district which is having higher IFR number, which is Balai Endah, situated in 618 meter above sea level, having 0.15% of IFR number, making it the highest IFR in the Bandung Regency. So the sub-district who is situated in the highest elevation is also the sub-district who have lowest IFR number, situated in 1,600 meter above sea level, having 0 deaths and 1 confirmed cases, make it the IFR number itself 0, because no deaths cases recorded as per September 2020. And in Bandung City, we're going to spot little difference between the sub-district who is the lowest elevation and sub-district which is having highest IFR number. It is different, but the difference itself is not that much, because the sub-district who is having highest IFR number, which is Ticendo, not situated in the lowest elevation in Bandung City, but in case of population, it have more population. In case of density, it is more densely populated. The elevation itself is not that vary, so the population is also could make a bigger harm exposure toward the coronavirus cases. But we can confirm that it is not too much different. To the number of deaths itself, it is 1 different, and also to the IFR number itself, it is 0.05% difference. And also the sub-district who is situated in the highest elevation, which is Sukajadi and Sukasari, situated in 856 meter above sea level, and both 856 meter above sea level, having 0.05% IFR number and 0% IFR number respectively. But the confirmed cases itself is quite many in numbers, 34 and 14 respectively. So what we're going to cite this is that the recovery number in this preliminary result could also confirm that the recovery is more possible in the location with higher elevation. So the conclusion of this presentation is that the elevation level preliminarily correlated with infection fatality rate in Bandung City and Bandung Regency. Variables of air pollution, population, and population density are still determining to be the cofactors of IFR number itself, because we are not going to talk about elevation. We're also going to the driving factors of what make a COVID cases are more exposure to harm or less harm itself. And it is yet to be decided whether Bandung City and Bandung Regency indicates some certain level of fatality, as there is no universal parameter for the fatality itself. Each regions, each places has their own range of IFR numbers, so we cannot connect it to the universal parameter itself, but hope further researchers will actually make certain research about what number could be defined as harm, what number could be defined as less harm, and what number could be defined as the not so harm itself for the people. And last but not least, we also want to state that the infection fatality ratio shown in this research is the general IFR itself. There are also other researchers who showing IFR based on gender, IFR based on comorbidities, IFR based on age range, but what make it hard to be taken into account in our research is that kind of data doesn't well stated or explicitly stated in Bandung City and Bandung Regency. So the hard process of getting those data, because those data haven't been documented, making it hard for the researchers to make a specific IFR number. So thank you very much. That's my presentation on the abstract of the presentation itself. I would like to say thank you and hope the further research will make more clear justification and clearer proof toward the matter we're concerned. Thank you.